Good morning. Welcome to part 2 of our TPC training webinar on electrical safety. Today we're going to focus solely on personal protective equipment. It's one part of electrical safety that is usually included in any kind of electrical safety training program, but tends to get sort of second billing to things such as arc flash and NFPA rules, so on and so forth. So today we're going to focus exclusively on PPE. And maybe it's an appropriate topic considering that today is Friday the 13th, and so we're going to talk about protective equipment and safety, but we will not be talking about things such as walking under ladders and black cats and broken mirrors and such. So we're going to keep it specifically to electrical safety. Now, our instructor today is Ryan Smith. Ryan has been with TPC training for a number of years. And Ryan's going to go through the presentation, but at the end we're going to talk about some questions that you may have. So we're going to do that in a couple of ways. There is a question bar, a chat bar there on the right-hand side of your screen. And if you have any questions there, please enter in your questions into that question bar, and we'll answer those at the end of the presentation. Some of the most popular questions we get tend to be, can we get a copy of the presentation? And the answer to that is absolutely yes. At the conclusion of the presentation, you'll receive a thank you email from us. Just respond to that email and we will get that sent out to you. We can also do a recorded copy of the presentation, and that way if you need to get a video of it, you can absolutely do that as well. So without further ado, oh, I'm sorry, one more thing. We do have another webinar coming up on troubleshooting. So if you're interested in all things troubleshooting, both mechanical and electrical, you can get signed up for that. I actually just sent a registration link over the chat bar there on the right-hand side. So if you have any questions about that, or if you want to get signed up for that webinar, please do. Without further ado, I'll turn it over to our presenter, Ryan Smith.
Hey everyone. Thanks so much for being here on our webinar, and we're going to spend the next 45 minutes or so just talking about all the latest electrical PPE requirements, but also do a little shopping trip online to see, you know, what kind of electrical PPE is out there, and how much might it cost us as well. So just to give you an idea of us as a company, TPC Training is fully focused on being your total training solution. So basically anything your people need, from technical, soft skills, corporate training side of things, we're here to provide that for you. So we offer live instructor-led training, which, you know, is one of our high quality products, where you can actually come into the classroom with us either in your own facility or come to any of our several hundred open enrollment sessions throughout the year. We also have online training where you can take self-guided training courses at your own pace, as well as some interactive process mapping tools where you can put all the documentation for your machines and your facility in an interactive, clickable tool. And so it's a really easy, awesome way to train all your people in your facility, including all your operators. So we have a lot of solutions out there, and especially on the topic of electrical safety is a big expertise area of our company for sure. So this is me. My name's Ryan Smith. I've been in the industry for over 12 years now, working on a bunch of different jobs and projects throughout the years. I was a technical training director at a large manufacturing plant at actually a plastics recycling center back in Michigan for a number of years before coming to here at TPC Training. Been an instructor here teaching a lot of our electrical based classes for the last 3 years, and now I'm our product manager of our classes, making sure that they are good quality, up to date with all the latest information. So I'm really passionate about helping people learn and taking the approach of, you know, not all engineers, they say, like to work with people, but I'm one of those few that do. So that's a little bit about me. So what are we going to talk about over the next few minutes? Well, I want to get into talking about PPE, all about PPE. And the first thing we got to do to understand what PPE is all about is talk about the terminology of PPE. When we look at the tag of PPE and look at, let's say, at an ATPV value or an EBT value, and talking about calories and FR versus arc rated and all this stuff, we really have to know what that means for us. Also looking at the PPE categories, I'm sure many of you who are working in and out on electrical equipment have seen the whole category system, but what does it really mean? And also, what is the alternative to using categories in your facility? Types of equipment we need to wear in different applications. So now that you know the category, when do you know to wear which category? We're going to talk a little bit about that and break that down from our national regulation, NFPA 70E. And believe it or not, and you're going to see this here, you might not think of a meter, you know, the little multimeter you hold in your hand with the red and black lead is a piece of PPE, but I'm going to hopefully convince you on this that absolutely a meter should be considered PPE, as well as some of these voltage rated tools, you know, with the orange handles, the insulated handles, those should also be considered PPE as far as you're concerned, and we're going to talk about why. And then at the end, I incorporated here, special for this webinar, a little shopping trip. So just a little bit of we're going to go around the internet a little bit and see what kind of ARC rated and electrical PPE is out there, and see if we can make heads or tails of it. So before we get into the PPE itself, I just want to know why are we wearing it and what are we protecting ourselves from? So if I were to ask any of you on the call, you know, what are the ways we can hurt ourselves on electricity, you would find that there are three different main ways we can really hurt ourselves. And the first that might come to mind is you're in a panel and you make direct contact, right, with electrical part, right, where that current is flowing through your body and causing your heart to fluctuate or even stop in certain cases, and you lose all control of muscle function. That is what we call electrical shock. Really bad, really, really dangerous for the health. In fractions of 1 amp of current can kill you. So we have to have PPE that can protect us from an electrical shock. Next is the kind of new buzzword, and that's what we're talking about a lot today, and that is arc flash. So what you see in this still picture is a still of an actual arc flash incident happening out of a panel. You can see that this is hard to distinguish from an explosion, right? And it really is. It's an extreme amount of heat and light and energy coming out of a panel suddenly and unexpectedly, in which case you can get serious burns and blindness as well from these types of things. So really what we're trying to protect ourselves from is serious burns from an arc flash. And then finally, an arc flash that's gone unstopped and unhindered and just allowed to happen from head to toe, and really it's just a horrible, devastating explosion, and that's called an arc blast. So this is an arc flash gone unstopped and unchecked. So these are the three main ways we can hurt ourselves, and it's up to us to make sure we protect ourselves from these hazards. Pretty important stuff here. So the reason why this stuff is so important to us, and kind of underscoring the importance of all this PPE requirements, this is all documented in the yellow book you see here, NFPA 70E. So this is actually not the 2015, but the 2018 version. So the 2015 version of NFPA 70E came out 3 years ago, and this new 2018 version came out just 6 months ago, or actually 8 months ago, back in October of 2017. And it's all the latest and greatest. So anything you hear from me today is going to be all out of this latest and greatest yellow book of NFPA 70E. Now what you might notice on the cover of this book, that there's a little pyramid here that indicates the 6 levels of protection. Now I'm not going to get into that pyramid too much with you guys today, but I just want you to be aware that personal protective equipment, PPE, it should actually be the last thing you consider, the last line of defense, we call it, in protecting yourself. Now, what do we mean by that? Why should PPE be the last thing we consider? Because once you're wearing PPE, if you think about it, you're already putting yourself in harm's way. You're already exposing yourself to the extreme dangers of whatever's in the panel right in front of you. And you've exhausted all other options, because if you think about what's at the top of this pyramid, it's called elimination. What if we just shut down the power going into that panel altogether? Which means we wouldn't need PPE because there'd be no electrical energy there to hurt us. So really, PPE should be considered a last line of defense. But even so, millions of people, across this country are resorting to doing live work for the sake of troubleshooting, day in and day out to troubleshoot electrical panels, as well as needing to keep their hazardous equipment like fire alarms and fire sprinklers running constantly. They can't shut those things down. So for this reason, we're looking into PPE today. I would say the first most important thing about PPE to understand is what we call an ARC rating on that PPE. So this is talking about protection from that second aspect, and that is the arc flash. So as you saw, these giant fireballs that come out of the panel unexpectedly, they can happen for a number of reasons. First and foremost, it could be really what happens. I guess the way to explain what an arc flash is and what causes it is whenever electrical current decides to flow through the air around us is when one of those horrible, dangerous, very, very hot arc flashes occur. So that can happen when an electrical tool is dropped on accident, right? We're all clumsy human beings, and those electrons can flow to the metal tip of a screwdriver that we dropped, or a wrench, or maybe our metal rimmed glasses or our watch that we're wearing on our bodies, things like that. And once electrons see a path through the air to flow, an arc flash happens shortly thereafter. So it can happen just on accident, and really human error is one of the main causes of an arc flash. So we got to protect ourselves for any incidental arc flash. And for that reason, we need an arc rating on any clothing that we wear. Well, you might say, well, what kind of arc rating do I need? Well, the key here, the key element we're looking at is called calories per centimeter squared right here. Okay? Calories per centimeter squared. This is the rating of how hot or how much energy is in an arc flash. The more calories, the more heat that there is in an arc flash. And so the calories on let's say the tag of a piece of clothing is going to tell us exactly how much heat that piece of clothing can withstand before it either A, breaks apart, comes apart and exposes your skin, or B, catches on fire from that heat, which is obviously something we don't want. If we're wearing a piece of clothing protecting us from an arc flash, we do not want it to catch on fire when it sees that arc flash. And you better believe it, guys, that polyester or cotton or anything in between is going to catch on fire and cause serious injuries for you. Now, one of the biggest myths in our business is that wearing 100% cotton clothing is going to protect us from an arc flash. That is absolutely false. And we have to know that it doesn't matter if it's cotton or polyester blend, it's going to catch on fire if we're wearing it. So let's say wearing a 100% cotton long sleeve shirt. That's not going to protect us from an arc flash. What is talked about for 100% cotton is any under layers underneath the arc rated clothing. So that means, the t-shirt that you wear under your arc rated shirt, or the underwear you wear under your arc rated shirt, that should be 100% cotton and non-polyester, no nylon, no rayon, no anything like that. So that is one thing to consider here. So let's take a look at what the outer layer should have. So let's say a shirt had this tag, right? I challenge everyone on this call to go back to your facility and take a look at your tags of your equipment and to see if it matches up to what we're talking about today. So this one, for anything to be properly arc rated, there has to be a specific calories per centimeter squared. And you see on this one, here it is, 12.2 calories. Now it calls an ATPV value. So what you can see here is an ATPV is called an arc thermal performance value. Now this is the one where it will catch on fire at this threshold. So this shirt in particular can resist catching on fire up until 12.2 calories of heat coming out of a panel. Just to give you an idea of what a calorie is, guys, if you imagine a cigarette lighter with a tiny little flame coming off of it, a cigarette lighter is about 1 calorie per centimeter squared, that little tiny cigarette lighter. So if you might say, okay, well, how many calories does it take to be dangerous to me and to give me let's say a second-degree burn on my skin? You might be surprised, because all it takes, if a lighter is 1 calorie, all it takes is 1.2 calories to give me a second-degree burn on my skin. So what we're talking about is that this shirt that we're looking at on this slide here can withstand 10 times more heat than what can give us a burn on our skin. Now just let that set in for a second. That is an amazing amount of technology that has been developed only in the last 15 years of our existence here. Really ever since the 2000s when we started seeing these arc flash clothing requirements. We've seen the way materials have been weaved together in a special way that really allows for us to see significant protection that we didn't otherwise see. And since this was proven in our industry, it became a requirement out of the book. I mean, it speaks for itself that it has saved so many lives by avoiding people from catching on fire. Is that to say that arc flashes didn't happen before the 2000s? Absolutely not, right? They've been happening ever since the existence of electricity over the last century. But we haven't really been able to do anything about it until now. So why not wear some of these advanced pieces of equipment? And why not be very diligent about knowing what calories are and knowing where to find them? Now you might ask, well, how do I know how many calories I need to wear on my equipment? And I'll just say, take our electrical safety class to find out more. And I'll just say that there are labels on any piece of equipment, any panel board, any circuit breaker box, any control panel should be labeled with exactly the amount of calories you need to protect yourself from. And if that label is not there, you guys might be facing, the National Electrical Code problems at that point, because that's been a requirement for about 10 years now. So it's really important to have these labels and then match up from the labels on your equipment to the stuff that you see in the field. Here's kind of a new thing that's been happening since the 2018 go around. I'm sure maybe you've all heard of FR, flame resistant or flame retardant clothing, okay? Now that's really important to have FR clothing. But FR clothing is not only what we're looking for, okay? So if you see a shirt that says FR, right? Oh, this is an FR shirt. That does not necessarily mean that it's going to protect you from an arc flash. What you need to look for is specifically arc rated clothing. Okay. That's really the key here. So I guess one way to put it is that all arc rated clothing is FR, but not all FR is arc rated. If you think about it, like firefighters, for instance, their clothing is flame resistant, flame retardant, but it's going to protect them from flames, of average everyday fires. Whereas an arc flash, did you guys know an arc flash can reach 35,000 degrees Fahrenheit in an instant? That's 4 times hotter than the surface of the sun. So we need really special clothing to be able to withstand that sudden blast of heat in a short period of time, and that's what we call arc rated. So FR is no longer good enough. Okay. So there's certain care you need to take for any of your PPE. Arc-rated clothing usually only lasts an average to 12 to 16 months. So really, these don't last long, and you might think, wow, you'll see how expensive these are in a second. But would you want to risk your life by having, a shoddy or maybe having a tear or a hole or contamination on an arc-rated piece of clothing? Absolutely not. So that's why these requirements are so stringent. And you can find most of these in the manual or the instructions for any given piece of arc-rated clothing that you buy on how to keep it clean. Generally speaking, the recommendation is that if you see any dirt or oil or chemicals, which is pretty common in the maintenance field, right? We get oil, we get stains on our clothing. But for arc-rated clothing, guys, if you see any of those permanent stains and you can't get them off, you got to throw that thing away and get another one. It's as simple as that. Because imagine this: you have oil stuck on your arc-rated shirt, and you experience an arc flash, right? You didn't see it coming, but it happens. Is that oil going to ignite? Absolutely, it's going to ignite, and that totally invalidates the need for the arc rating on that thing. It totally invalidates it, and it's going to catch fire anyway. So we really don't want that to happen. So any dirt, any soiling, and even any small tears and cuts is grounds for getting rid of the arc-rated clothing. As well as laundry, right? Laundry is a big hot topic of contention out there today. And a lot of companies are deciding whether to do an industrial laundry service or wash these things at home. So there's arguments to be said on both sides of these. Industrial laundering, you know what you're getting each time, but industrial laundering can also really reduce the lifetime of your clothing because of how hard they wash these things. So, recommendations a lot of times is, hey, wash these at home as long as you can make sure that you're washing it with mild detergent. By that we mean no fabric softeners, no starches, no anything like that, because the reason fabric softeners work is they leave particles on your clothing to make it feel soft. Well, those particles are, in most cases, flammable particles. So you don't want to have to use them. You want whatever detergent you use to wash completely away from these things. And again, always inspect for damage before each use, and that is right out of the code book. So here's a couple example pieces of arc-rated clothing. Now, maybe what came to mind for you before was what this guy's wearing, kind of the Homer Simpson looking, chemical looking, space suit. But really, arc-rated clothing has advanced so much even over the last 10 years that you can look like the guy on the right here. This looks like an average everyday work clothing, and these are all arc-rated pieces of clothing, including you can get arc-rated belts too. We're going to see that in just a little while. So let's just briefly talk about those PPE categories, and we're going to come back to them in just a few minutes. So the book, the NFPA code book, calls out 4 different types of PPE categories. And these categories are only valid for you if you are using the 4-category method in your facility. So your facility might be using the 4 PPE categories, or they might be using straight up calories, and you just have to match the calories. If you're just using calories, which is what we call the incident energy analysis method, you can ignore this slide. Right? But if you're using the 4 categories in your facility, you got to pay close attention. There's category 1, 2, 3, and 4, and we're going to break these down later, but you can kind of see category 1 is a little bit lighter. We don't have to worry as much, and it's going to protect us up to 4 calories, or at least 4 calories, I should say, is the minimum protection to have for category 1. And that includes a face shield and a long sleeve shirt and pants and gloves. But now we have to start wearing a balaclava, this sock hood we call it, an arc-rated balaclava, to protect the back of our head and our ears and our neck, category 2. And then category 3 and 4, we can't get away with any of those face shields anymore. We have to wear full suits, basically space suit hoods. We call arc flash suit hoods, rated for much higher calories, 25 and 40. We'll talk more about that. The headgear is what really separates these different categories from one another. And here's a balaclava you see here, again, made of a special arc-rated material, and you have to look at the tag of that balaclava to make sure it matches at least 8 calories if you're looking for category 2. Category 2 is the one that uses the balaclava in almost every case. Now, for these face shields, the face shield itself should be marked with an arc rating, but also you want to take a look at the hard hat that comes attached. That hard hat should be what we call Class E hard hat. And that is a denotation from the national standards to say that this is rated for 20,000 volts of direct contact protection. Now you might say, well, a wire's not going to come out of the ceiling and touch my head. You might be surprised, and that definitely probably won't happen, but the reason we wear electrically rated hard hats as part of our overall system is if you're in a panel, imagine a panel right in front of you, and you're putting your red and black leads in there doing some troubleshooting, and you accidentally drop the black lead on accident. What is your first impulse, right? You're gonna move your head toward that panel and try to pick it up, right? And your head would touch the live parts of that panel, and it happens to even the best of us, and it's killed and severely injured many people who just don't realize where their head is at. That's kind of the whole reason for hard hats to begin with, and particularly electrically rated hard hats. So make sure that your hard hat on the inner labeling is Class E. And you see this suit hood here is rated for, let's say, up to 25, 40 calories, 100 calories in some cases we're going to see. Now, calories is, 12 calories is some serious heat, right? And you're going to see if we're using the calorie method, not the 4 categories, but the incident energy method, you're going to see that this hood is going to be required for anything above 12 calories. So that's a little bit about clothing, and we're going to jump back into it in a second, but let's talk about meters. You might say a test instrument is not a piece of PPE, and I've definitely had this discussion a few times with some students in our classes. But just take a look at this straight out of the book, straight out of NFPA 70E. It's Article 250. It talks about caring for your equipment, and it says right here, personal safety and protective equipment such as the following shall be maintained in a safe working condition. And look at this right here, number 4, test instruments. That is our multimeters, guys, as well as any hot sticks you see in number 2 and anything else. Now, why do you think the book is now including, right, because all this gray stuff is brand new information. Now, why do you think they're including our meters as one of our pieces of equipment, as well as all of our, arc-rated clothing and our gloves and everything else? That is because, if you think about it, the only thing between you and all that intense amount of energy in that panel, when you're taking measurement readings, right, is that meter. It's only those little red and black leads and the little meter itself between you and that hazard. So you don't want something like this, right? This meter here that completely blew up in someone's hand to be you, okay? People have gotten seriously injured and killed just from a meter that wasn't properly inspected or properly rated for the job. For instance, if you take a meter that's only rated for 600 volts and you touch it to 1,000 volts, you better believe that that thing's going to blow up. Or in the case that it's not able to handle what we call the transients or the spikes of current and voltage that happen for short periods of time, it's going to blow up in your hand. And so those transients protection is what we call a category on the meter. So that's really important to know as well. So you could have the wrong settings where you're maybe trying to measure ohms when testing voltage on accident. You use the wrong category, which there's 4 of them, not to be confused with PPE categories. We'll talk about that. Wrong probe socket, or the wrong voltage was applied, like we talked about. So looking at the voltage rating is one thing, but also looking at the category is another. So the way I like to describe categories for you guys is that the higher the category, the better. And us at TPC Training, we recommend, if at all possible, just get yourself a Category 4 meter and call it good, because a Category 4 meter can withstand all of the things that all the other categories can withstand and more. So why not use a Category 4 meter? And you can take a Category 4 meter and go indoors and test a tiny 9-volt battery if you wanted to, no problem. So basically, Category 1 can only withstand small transients that you might see on tabletop equipment or small pieces of equipment. Category 2 can get into branch circuit level stuff, at 208, 120 volts, plugs and outlets, that kind of stuff. Category 3 is for industrial, so 480 volt motors, switch gear, panel boards, indoors. But as soon as you walk outdoors for any reason and you're getting closer to that transformer, you need Category 4. So basically, the higher short circuit that can happen, the higher the category is going to be, plain and simple. We talked about this as well. So meters nowadays, just like any other piece of PPE, have come a long way. Meters used to literally just be kind of little chunks of plastic that could maybe give you a little readout and a voltage, and that's it, like voltmeters, right? Or amp meters, which were amp meters only. But nowadays, most meters can take all the readings we need and more. And you've got to be careful too, because some meters might sacrifice their category to give you a higher voltage rating. For instance, this guy here. This one, Category 3 at 1,000 volts. So this one can be used indoors up to 1,000 volts. But if you want to step outdoors with this thing, you can only get up to 600 volts safely. So you got to be really careful about understanding the categories. And one other thing I might say is that a meter might tell you what the category is, let's say somewhere up on the meter itself, and then it might tell you a different category when you look down at the black and red ports down there. And let's say if the top of the meter says it's Category 3, and then the ports themselves say they're Category 2, what category is our meter? Well, turns out it's going to be only Category 2. And if we also check our leads that might come out of this meter, I know I'm scribbling, but if we have 2 leads coming out of the meter, each lead has its own category as well. So each category, or each component of a meter system has its own category, and you want to just go with the weakest link just to make sure. My next question to pose to anyone might be, how do I really know that a meter can withstand the 600 volts? that it tells us it can, right? Should I just trust the little bit of white paint that's on the front with my life, that I'm going to touch 600 volts and be safe? Absolutely not. And this goes with any piece of equipment, including our gloves and our clothing, is that you want to look for a UL listing, a listing. And it's going to look like something like this, right? You got to look for this emblem that it has been listed from the underwriter's laboratory or any other similar or equivalent testing agency. There's 30 of them recognized across this country. Here's CSA. The second one is from the Canadian Standards Association for use in Canada. This TUV is a big testing agency across Europe and in the United States as well. Okay. And again, our meters are able to do all sorts of stuff for us nowadays, including backlights and magnetic hangers, so you don't have to hold on to the meter. You can plug in a thermocouple into this thing and start measuring temperature. They're much more accurate, and they can take minimums and maximums, and you can replace their batteries now, which is a great plus. So there's a lot of great advancements there. And again, the category is all about withstanding transients of up to 12 to 15 times more than the actual rating of the working voltage. And that's why we use higher categories. Okay, now let's talk about the arc flash PPE method. Okay, and that this is the, let's talk about the first method, which is the incident energy method. So if you walk up to one of your panels and it says 7.4 calories, right? Well, what do I do? What piece of equipment do I need to wear to be safe walking into that panel that says 7.4 calories? Well, a guideline has been offered by the NFPA 70E of two different intervals. One is the interval from 1.2 calories, and you might recall that's the threshold that gives us a second-degree burn on our skin, all the way up to 12 calories. You can get away with wearing this type of shirt, or this type of clothing, including arc-rated shirt. First one being arc-rated clothing with an arc rating equal to or greater than the estimated incident energy. A long sleeve shirt and pants, right? So in other words, we can't get away with shorts, we can't get away with t-shirts, they are not going to be acceptable. Arc-rated face shield and an arc-rated balaclava. Do you guys remember that balaclava, that sock hood? You have to wear a sock hood at all times, according to this method. You can't get away with just a face shield. Heavy-duty leather gloves. Guys, I would say this is the most critical component of any electrical PPE are those gloves. You guys saw that guy's bare hand touching live parts before. The gloves are the main thing protecting us from electrical shock that we're wearing. Did you guys know that your arc-rated clothing, your shirt, your pants, your face shield, they are not designed at all to protect you from shock, right? Except for that hard hat on your head and the gloves on your hands, nothing else is there to protect you from shock. It's all about heat from that arc flash. So you got to make sure those gloves that you're wearing are in tip-top condition, just like everything else. Now, how often do I have to test my gloves? Every single time I use them, I need to test them. Doesn't mean you have to take them into a lab and test them. It means you have to inspect them, look at your gloves, and then take the black rubber, right, actual voltage rated part of the glove, and squeeze off the end of the glove and start rolling it up. And you're going to trap air inside that glove, and that glove is going to start blowing up like a balloon, right? And when that happens, what will it happen if there's even a pinhole in that glove, right? You're going to start hearing that air escape the glove. And if you hear that air escape, or if you're in a loud manufacturing environment like I was, you hold the glove up to your face and see if it you feel any of that airflow against your face, because your face is very sensitive to movement of air. Then you can say, okay, that is what we need, this is something bad, and what I need to do is literally throw away the glove, even if there's a pinhole. Because imagine, can electrons from a circuit flow through a pinhole? And the answer is absolutely yes, and you're going to feel the full force of that electrical shock just like you weren't wearing gloves at all. Okay. So again, we got to be very strict about the condition of our voltage-rated gloves, and also wear those white leather protectors over them, because these gloves are very susceptible to cuts and scrapes. Okay. And did you guys know we have to wear safety glasses? Even though we're already wearing a face shield, we also have to wear safety glasses or goggles under that face shield. because the face shield's not really protecting our eyes from the day-to-day dust and particles like they usually do. And also hearing protection. Even if you're in a quiet house or a quiet office, you have to wear earplugs when working on live equipment, because you're going to be very thankful if you experience an arc flash, which can get up to 160 decibels. 140 decibels is enough to rupture your eardrums. Just think about that. And another interesting topic for discussion here is leather footwear. Interesting. What is the footwear requirement out of NFPA 70E? Well, did you know we don't have to wear that so-called EH-rated footwear necessarily? And we don't have to wear dielectric footwear necessarily. Right? They actually don't get into the battle too much of a footwear, because if you imagine a panel, it's right in front of you. And if an arc flash or even a shock happens in that panel, what is the likelihood that what you're wearing on your feet on the ground is really going to protect you from the movement of those electrons? And the answer, according to the national standard now, is it's not going to protect you all that much at all. And their shoes, right? They get dirt on them, they get grime, they get oily, and that's understandable. And so once they are oily and grimy, they're not going to protect you from a path of electrons to flow anyway. So really, the standards don't get into them, but they do mention if you're going to use them, they better be EH rated and dielectric rated if you're going to use them to protect you from electrical shock. For instance, if there are wires at foot level that have a danger of making direct contact with your feet, then that is a good enough reason to use EH or dielectric footwear. Otherwise, they just say leather footwear. That's about it. If you're going greater than 12 calories, the only difference here is arc flash suit hood. That big suit hood needs to be worn instead of the balaclava. So let's say it's 27 calories. Well, you better wear an arc rated suit hood rated for 27 or more calories. So they get into all the different stuff we've been talking about. You want to make sure there's adequate movability. The head, the face, the neck, the chin are protected using that balaclava or the face shield. Eye protection, right, which is our safety goggles. We need hearing protection. We need bodily protection. We can't get away with short sleeve shirts, guys. In fact, any exposed skin we almost can never get away with. Make sure every freckle, every piece of hair that you have is underneath something. Shock protection. It's all about those gloves when we're talking about shock protection. And yes, the gloves need to be tested every day, but then you do need to send them back to an official laboratory every 6 months. And even so, even if you never even opened the package of the gloves, let's say you got them in and you just put them on a shelf without even opening them, you still got to send them back within 12 months. Because gloves can degrade and break down over time, even sitting on the shelf. Talk about foot protection, again, only if they're used as protection against step and touch potential. That means direct touch with live parts, then we'll have to use dielectric footwear. So look at this one. This black arc flash suit hood weighs about 15 pounds and can protect us from a significant amount of calories. Look at this, 140 calories. So these things have come a long way to becoming not just stiff and hot. And I know a lot of electrical guys have complained to me about, oh, I don't want to wear arc-rated clothing. It's hot, it's sweaty. It's going to make, I love this, it's going to make my job more dangerous just by wearing it. Right? I got that so many times in the past, and it's something to just think about. Are you willing to roll the dice every time you get into a panel just because you want to be a little bit more comfortable for those 10 minutes you're in there? Would you rather save yourself 10 minutes of comfort than really put your entire rest of your life at risk? Would you be willing to pull out 2 pairs of dice today out of your pocket, roll them, and if you roll snake eyes, you're going to die today? Would you want to play those odds? Or would you like to actually put the dice on the table and not even have to play the odds because you can assure your own safety? That's what PPE is all about, assuring your safety in the face of electrical danger. A lot of maintenance guys, time and again, are willing to be all proud and you know, show that they're a better man or whatever by saying, oh, I'm just going to, you know, play the odds, or I'm going to take the risk, you know, just because it's easier or more convenient or more comfortable. But it's never more safe. I'll never accept that argument that it's more safe to not wear gloves or to not wear PPE than it is to wear the PPE. It's been proven time and again to save people's lives. So let's do it. I'm going to move forward here just a little bit. Everything's got to be properly marked in our PPE categories. Here they are once more. Now, there's a table out of the book that says, okay, when do I need to wear these categories? I'll just break down that table for you for just a second. So this guy, wearing 4 calorie rated stuff, if we're going to use the category method, you're going to wear what this first guy's wearing. If you're in a probably 120 volt up to 240 volt panels, working on smaller 208, 240 volt equipment that has faster acting fuses, okay, and circuit breakers. Now the trip time of your circuit breakers is really important here. So that's why you can't just tell me what PPE you're going to wear unless someone has come in and applied those labels after doing a professional analysis for you. Category 2, this is when we get into 480 volts. If you're starting to work on 480 volts, you could be wearing category 2, but you could also be wearing category 4 way over here at 480 volts. So just be aware of that. How do you know which one it's going to be? Well, it all depends on how fast those fuses break and how big those transformers are feeding those fuses. Why not? What about category 3? Well, we actually do not get into category 3 with typical AC facility equipment. When you're dealing with DC, high current level and high short circuit level equipment, that's when we start seeing category 3. And here's the table that talks about it. Just give you a quick kind of breeze. The category 1, 2, 2, 4. So we could go from category 2 all the way up to category 4 depending on where we are. You can see that starting at 600 volt class equipment, we start looking at category 2. And the only time we can get away with category 1 is stuff rated 240 volts and below. And again, our insulated tools and equipment, like this kind of stuff, is also included in our list of PPE and should be inspected and in good quality, just like anything else. And did you guys know if you're getting closer than 12 inches to your, let's say, 120 volt to 480 volt equipment, you are required to have these insulated tools with you to protect yourself. It's right out of the book. You must be wearing, or you must bring with you insulated tools and equipment to the job if you're going to be getting closer than 12 inches to live parts. So that's kind of a quick breakdown for you guys. I only have a couple more minutes, but I want to go shopping with you just for a couple minutes. Let's go shopping. Let's go just take some screenshots of some online shopping that I went through and see what's out there. Here's something you found online. 100 calorie level suit with a short coat and a bib available. Take a look at the price. This is not cheap. $2,400 for an outfit, right? Again, this stuff is not cheap, and it's here to save our lives, and it's undergone significant manufacturing and testing to make sure that it can protect you. So these are an investment, to be sure, for any company. But ensuring that these are in good quality should be paramount, right? So that you don't waste that money. Looking at the gloves themselves, this is really interesting. So you can get those voltage-rated gloves, which are, the black rubber that comes with the white leather protectors that are in the pouch to go over them, which is typically what we wear on the job. Or another option you might have seen on the list before is you can get arc-rated gloves if you're going to be within. And look at this one. These are rated for up to 100 calories. But don't think you can get away with the arc-rated gloves as a single glove solution, so you don't have to wear the two rubber gloves. Because if you look closer, look at this. First of all, these are $190 gloves. But then secondly, note, these gloves are not voltage rated and are not for electrical protection. Your mouth might hit the floor looking at that. I thought these are calorie rated, and they absolutely are for arc flash protection, but they aren't rated for direct contact with live parts. So really, I show this to you just so you can really closely look at each thing and what it's capable of and make sure it's going to meet your needs. So yeah, you can wear these within the arc flash boundary that you can learn more about when going, to get our certification for electrical safety in one of our classes. But they're not going to be quite good enough for arc flash or for electrical direct protection. Here's a hood, right? Here's an 100 calorie rated hood. Again, 100 calories was unheard of. That's almost 100 times more than what can give you a burn. But for $812, you can get something that can protect you from that level of heat. Some other interesting stuff that's out there. Look at this $930 blanket, right? So this is an arc-rated, calorie-rated blanket. or is it, right? So again, this makes you think, right? Anything with an ARC rating we talked about before has to have calories. Well, this one only has an ARC rating of a certain amount of amps. So if you look closer and you start reading, this can withstand 362 cycles. It's good for NFPA 7E, but it doesn't really tell you how many calories of heat it can withstand. So would you feel comfortable buying this to protect, someone from an arc flash? Absolutely not. We have to rely on that clue. Here's a balaclava. And another thing to watch out for, it says HRC category, hazard risk category, right? It says category 3. And we look at it's rated for 30 calories. And we remember category 3 is 25. So we're like, okay, that's good. And then it says down here, it's rated for only category 2. Interesting. So they're not matching. So you want to just be very aware of what you're getting yourself into and make sure you come to this as a knowledgeable employee. Here's one of those EH-rated boots we talked about, and making sure that these are properly EH-rated. That you get an ASTM standard, the American Standards Institutes, make sure that it is up to those standards. And there's ARC-rated a lot of stuff nowadays, and just kind of give you a fun taste of this. We have ARC-rated sweatshirts. Right? Now, can you get away with an ARC-rated sweatshirt? Not necessarily. You need that long sleeve shirt, right? It says so, but you need to make sure that it is properly ARC-rated for your application. This one's rated for up to 28 calories, just a sweatshirt, right? ARC-rated jeans exist, ARC-rated blue jeans, right? These ones in particular are rated for up to 16 calories. So you can be looking like a normal person and be completely protected from an arc flash. Now here's an interesting one, ARC-rated short sleeve shirt. Can you get away with this ARC-rated short sleeve shirt on the field? Like we talked about, absolutely not. So why even sell one if you can't wear it for ARC-rated protection? Well, what if you wore this ARC-rated shirt as an underlayer to your overall long sleeve shirt? Now you'd be getting some significantly higher protection than just a regular cotton undershirt. Now, do you add them up? A lot of people have asked me, if I have a 6-calorie rated t-shirt underneath and then another 6-calorie rated overshirt, does that mean I get 6 plus 6 and that's 12? And the answer is no, absolutely not. Not necessarily. But what you might be surprised to find out is that most likely your categories of protection are going to be much higher than 6 plus 6, because the air gap is also protecting you from the arc flash. So you could see way more than 6, but the only way to get an official answer to that is if the t-shirt and the overshirt come from the same manufacturer and they have been tested together as a pair to protect you from an arc flash, and they give you the specific arc rating of them as a pair. That's the only way to know for sure what your protection is going to be. Don't take, 2 different manufacturers, put them together and think you're meeting the requirement, because that's definitely not how it's going to work. Arc-rated parkas, arc-rated raincoats, those exist. And again, they're not cheap, but they're out there for our protection, and you can wear this rain or shine. There's a way to protect yourself from arc flash. Look at this, arc-rated hat, right? Arc-rated baseball cap. These things exist, right? This cap in particular can protect from 12 calories. Was that a way to get out? So this is an interesting one, because I wouldn't wear this, because is this a way to get out of wearing the Class E hard hat on your head? Absolutely not, right? And so really, this hat, I don't see a really feasible way of wearing it other than, looking cool. Arc-rated belt, a lot of people, need to wear belts, and these do exist, arcbelt.com, and from this one in particular. So it's a fairly new product, but these exist, right? Belts exist that can protect us from an arc flash. And the NFPA 70 book, finally, and kind of last but not least, they get into underwear, right? The NFPA 70 ebook is not afraid to talk about underwear, and neither should we be, right? We have to wear flame-resistant or 100% cotton underwear. Because you better believe if you wore polyester underwear or anything else, you're going to feel that if any of your waistband was showing. And the book even gets into the point of saying, hey, we know that all this underwear has a non-cotton waistband made of elastic, and that is acceptable. They say, okay, no problem. You can wear a waistband, but you better believe it's going to hurt. And you'll get a red ring around your waist if any part of your waistband is showing during an arc flash. But again, you can see look for calorie ratings, look for electrical ratings on your stuff. So these are two of our guys suited up, right? Two of our people at TPC Training suited up. And just to give you an idea of, wear this arc-rated equipment and be safe. And don't be afraid to look like a dork in front of your colleagues. Just wear your equipment, do it for your safety, and encourage everyone around you to do it as well. And make sure you're always looking at the tags of this PPE and shopping smart with all the new PPE that's out there. So if you ever want to learn more, definitely feel free to reach out to us at tpctraining.com. Call our number or go on our website at live.tpctraining.com and see where all the latest electrical safety 2-day intensive classes are. We talk more about where all these arc ratings come from, how to understand these labels, how to understand all the boundaries and calculations that go into these labels, and how to be that local expert in your facility on moving you forward for lockout, tagout, and safety stuff. We can also come to your facility. That's sales@tpctraining.com. And that being said, thank you for listening, and I am happy to be here to take any of your additional questions. Thanks so much.
Hey, Ryan, thanks very much. First question we have, again, please feel free to type in your questions on the toolbar on the right. If you do need a copy of the presentation, please just respond to the thank you email at the conclusion of the webinar, and we'll get that out to you very quickly. But the first question we have comes from a gentleman saying that his crew does maintenance, general maintenance, like changing light bulbs and testing duplex outlets. They do very little work on electrical, open electrical panels. So what category of clothing should they wear? Would that be a category 1, or could that be possibly category 2?
That's a great question. Testing light bulb sockets and duplex outlets. Now, he might not like to hear my answer, and I'm sure he might want to argue back with me, but did you know that putting the red and black lead inside of a plug of an outlet is considered live work according to NFPA 70E and all of our standards? So that means if you're ever putting a meter in just to get a 120 volt reading to make sure something's live, that is considered live work and requires any level of arc-rated protection. Now, the question is, what kind of arc-rated protection would I need? The answer would come, especially if you're in a commercial environment, which it sounds like you guys are. You have to go upstream of that plug and find out the circuit breaker box that's feeding it, and that box should be labeled, right, with the arc rating and the calories that it's going to happen. So if there's those 2 calories at the panel, then the same calories are available at that outlet. And so a lot of times, I'll just put this out there, a lot of times 120 volt and 208 volt panels, as long as they're fed from 75 kVA transformer or less, okay, and you can look at your one-line diagrams to find this out. Usually the rule of thumb is from our IEEE standards is you don't have to wear arc-rated clothing because it'll probably be less than 1.2 calories. But the only way to know for sure is if it's labeled with the calories that you're going to see. So let's say if it's 0.8 calories at the end of the day, you don't have to wear any arc-rated equipment at less than 1.2 calories because it's not going to give you a significant burn. But you and your guys cannot get away at all, ever, for any level of voltage to not wear voltage-rated gloves. Those are always done. Those should always be done regardless. And those safety goggles and the earplugs. Those are always going to be required during that live work. As well as, one more thing is, as well as never wearing conductive stuff. I'll hit that home one more time. Even if you're doing those electrical tests, you got to do, you got to take off your watches, you got to take off your necklaces and wedding rings and all that conductive stuff, no matter what you're doing.
All right, thanks, Ryan. We got a comment, so I'm going to try to formulate it into a question. But Ryan, can you touch on what PPE manufacturers are producing in terms of gear that is better fit for females on technical staffs?
That is a great question. So the website I was using for most of my my stuff here was the FR Safety website, and there were 3 main tabs. One was general. So one was general PPE. The other one was kind of accessories, like the belts and all that stuff. And then the third thing was specifically female fit PPE, and those absolutely exist, and they are out there and under consideration because more and more females are getting into the trades, and B, it's just a matter of proper fit and proper sewing and stitching of this stuff, and it's all out there. It all exists. But you're absolutely right. I mean, the electrician industry has known to be very male dominated, but the industry is moving forward and being progressive about it, and there is PPE out there for women as well as men.
All right, thanks, Ryan. Do electricians need to wear the correct rated PPE even if they're just turning on and off a circuit?
That is a really good question. So there is a table in NFPA 70E, and we provide this in a nice reference guide if you come to one of our electrical safety classes, about different activities you find yourself doing on a day in and day out basis. And let's see if I can find this real quick so I can give you the reference. But generally speaking, if you are working on, like let's say you open a circuit breaker box and you see the breakers in there, in all their slots, and you just got to switch off the circuit breaker, and you haven't taken off the protective panel or anything. You're not seeing any live wires. You're just flipping the circuit breaker from on to off or off to on. That is not something you need to worry about wearing PPE for. Normal operation of a circuit breaker. But, and I'll put a big but on this, you can only do that if that circuit breaker meets 6 criteria for being normally installed. So I'm going to refer you to table 130.5C, C as in cat. Okay, so 130.5C is where you can learn more about the different activities you might find yourself doing and whether there is or is not a likelihood of an arc flash happening to you. But you can only get away with not wearing something if that thing is properly installed, it's properly maintained, there's no evidence of failure. So if you walk up to the panel and it's making a buzzing sound, you probably don't want to flip that circuit breaker without wearing equipment, that kind of stuff. Or if it's hot to the touch or something like that. So again, not as cut and dry of yes or no, but you just have to make sure it's in good condition, then yes. Because there is an arc flash risk of flipping circuit breakers, for sure.
All right, thanks, Ryan. Ryan, are IR windows classified in any way as PPE?
IR windows. If they are built in to the panel itself, where you can, use them to shine the infrared scanning device through the window, so you can see what's going on inside the panel. If those are part, and I'll say again, the key word here is listed. If they are a listed part of the pre-assembled panel, then they are considered not really PPE more than they are what we call an engineering control for the arc flash. So they are part of basically the door to that panel. Now, if you're using one that you're bringing with you, let's say some sort of piece of plexiglass or something like that, it could, from my perspective, it's only good for arc rated protection if it has a calorie rating to it. Okay, and so if we don't know how much heat that thing can withstand before it melts and starts sticking to our faces, then it's really not legitimate for any sort of arc flash protection. And let it be known that if it's not part of the panel assembly, it's going to go flying, right? If there's an arc flash, it also sends a pressure wave out and makes people fly back and objects fly back at you. So if that thing isn't nailed down in a listed way, it's going to come at you. And so I wouldn't recommend at all making any IR windows or anything reliable for PPE.
All right, and I think we only have one more question. And this one seems pretty specific to someone's equipment. So the question is, they're troubleshooting on a transformer, let's say 20 kVA-480YO208.
Okay.
What category PPE do you think you'd need on that?
Oh, that's a great question. So if you're working on a live transformer and it's 480 volts, it sounds like it's 480 volts at the primary side and 208 on the secondary, or maybe getting at 480/277 on the primary side. First and foremost, you got to think about the highest voltage you're going to see, and that's going to be 480. Okay. From any 2 points that you could accidentally touch. So we got to look at the 480 volts. And then from there, we're looking at 20 kVA. It's it's pretty low, but we can only get away with the rule of thumb I mentioned earlier if the voltage was less than 208, which it isn't. It's at 480. So it could be category 2. If someone were to come in and do that analysis, it could be category 2, but it could be as high as category 4. It depends. It all depends on what's upstream of that transformer and how fast those fuses are going to break. So if you go back to that table I showed you, which is in Article 130 of NFPA 70E, if the circuit breakers or fuses that are upstream of that transformer, if they break in any slower than 6 cycles, which is 1/10 of a second, you could be facing having to wear a full suit with a full hood. Okay, but if those fuses or circuit breakers are more fast acting, and you can find the documentation of how fast they act, which is more complicated than it seems, and you can get into it more in our electrical safety classes, then if they are fast acting, you could get away with category 2, but there has to be a label. If there's no label, you're already kind of in murky water there about kind of playing the guessing game. So I'd say hire someone to come in, maybe someone who also labeled all your other equipment, and have them also look at labeling that transformer and what feeds that transformer.
All right, thanks, Ryan. That wraps up our questions. Any closing thoughts, Ryan?
I would just say definitely as homework for anyone on this call, go take a look at your PPE equipment and blow your gloves up like a balloon and take a look at all the labels and see what you really have and whether it matches what's in your facility. And hope that'll be really educational for you guys to want to learn more about safety. It's always a learning progress, and you're never done learning.
All right. Well, thank you very much, everyone. We hope to see you next month in August on our systematic troubleshooting webinar. But for now, we're going to sign off. Thank you very much for joining us, and have a great weekend.